Hey there, we're going to go over solving equations. Now, in physics, we have a lot of different equations that we can use. And those equations, sometimes they're not arranged for the variable that we actually need. And in those situations, we have to manipulate the equations and solve for the given variable that we're looking for so that we can then use that equation. So for example, let's say we have the equation acceleration is equal to change in velocity over change in time. But the problem wants me to solve for time. So in that situation, we have to then manipulate this equation to isolate time by itself so we could then solve for time. So we're going to go through some examples of different equations and how we can manipulate these equations to solve for a certain variable. And when we're going through this, there's going to be just a few steps that we're going to take. Okay, the first thing is you need to identify which variable it is that you're looking for. Okay, that's always going to be your first step. Identify your variable. So in this example here, time was going to be my variable that we're going to solve for. And then once you do that, you need to also look at the operations. Okay, so you need to identify what all operations are taking place in this equation. Once you do that, then you can actually start manipulating your equation and solving. In math class, you learned your order of operations, okay, and you probably remember that as PEMDAS. And so when you're doing this, we're actually going to go backwards. Okay, when we're manipulating an equation and solving an equation, we're going to go in the reverse order. So we're going to do reverse PEMDAS. And then you need to remember whenever you're doing this, what you do to one side, you have to do to the other. Okay, so if you divide by something on one side, you got to do that. You got to divide by the same thing on the other. If you multiply on one side, you got to multiply the other. Okay, so you got to do it on both sides. And lastly, it's always good to cross out whatever it is that is getting canceled out. So you want to cross things out. And sometimes it's important to rewrite the equation, especially whenever there's a lot of steps that you're going to have to do in order to solve the equation. Sometimes it's good to just rewrite it as you're working through it. Now let's look at a few examples. Let's start with one. Let's say that we have the equation P equals mv. And let's say that the problem wants me to solve for v. So we've identified that variable that we're looking for. It's v. And looking at the operations on that right side, uh, v is being multiplied by m. So we're going to do the opposite, right? We're going to do the opposite. We're going to divide by m. But remember, what you do to one side, you have to do to the other. So we're going to divide both sides by m. Let's cross out everything that's canceled, and then we'll rewrite our equation. So if we rewrite it, we'll have P over M is equal to V. And so now we have an equation that has V isolated, and that's what we're looking for. So then we could use that equation to solve for V. And here's another example. Let's say we have V is equal to this V subscript, it looks like an O, we call that V naught, plus AT. And let's say that the variable that we're going to solve for is A. And so we've identified our variable that we're going to be solving for. Now let's look at the operations. There on the right side, we have a addition taking place, right? And then we have a multiplication taking place. So A is multiplying by T, and then it's adding that V naught to it. So remember that step up here we said that we're going to do reverse PEMDAS. And the last two letters, A and S, in that is your adding and subtracting. So we're actually going to do that first because we're going in the reverse order. So since we're adding this V naught, we're going to subtract it, right? We're going to do the opposite. So we're going to subtract both sides by V naught. So this will cancel. Let's rewrite it. That would give me V minus V naught equals AT. So the next step here, A is being multiplied by T. We're going to do the opposite. We're going to divide by T. But what we do to one side, we have to do to both. So this whole thing over here is going to divide by T. The T's on the right side cancel. Now let's rewrite, and that would give me A is equal to V minus V naught all over T. So now we have an equation that has A isolated, and then we can use it to solve for A. Let's go through a few more of these. Here's an equation. We have K is equal to 1/2 mv squared. And let's say that we're going to solve for V. So there's our variable. Let's look at the operations. On the right side, we're just multiplying 1/2 times the m times the V squared. But the V is squared, so if we look back up here at our PEMDAS, the exponent, it's one of the first ones, right? We have parentheses, exponents. Then it's a multiplying and dividing. So we're going to do the multiplying, dividing, that part first before we touch that exponent. So we have 1/2 times the mass. So to get rid of the 1/2, what we'll do is we'll multiply both sides by 2, because 2 times 1/2 is just 1. But we have to do that to both sides. Let's cross out that, because that cancels. We can rewrite it. 2k is equal to mv squared. So we still have that exponent, but before we touch it, we still need to get rid of that m. Since it's m times v squared, we're going to do the opposite. We're going to divide by m, and we're going to do that on both sides. So now we are left with 2k over m is equal to v squared. So now we're on that exponent. Okay, it's being squared. So the opposite of that, then we'll take the square root. But we have to do that to both sides. We can cross out the squared and the square root. And finally, we can rewrite our equation. It's going to be v is equal to the square root of 2k all over m. And all of that is underneath the square root there. So here's another one. Let's say we have v is equal to delta x all over delta t, and I want to solve for delta t. Now, you need to be careful here whenever you're solving for something that's in the bottom of a fraction. I see a lot of mistakes here on these kind of manipulations. So the right side, it's delta x divided by delta t. So the first step that we're going to do here is we're going to multiply both sides by delta t. So we can cross out the delta t's on the right side, and let's rewrite it. V is equal to, v times delta t is equal to delta x. And now on the left, we have v multiplied by delta t. So the opposite of that is going to be divide, and we're going to divide by the v, and we're going to do that to both sides. So the v's cancel, and let's rewrite. We have delta t is equal to delta x all over v. And there is our equation that has delta t isolated. Here's another one. A is equal to this net force divided by mass. And let's solve for mass. Again, it's at the bottom of the fraction over here. So we're going to first multiply both sides by m. That will cancel the m on the right side. If we rewrote it, it'd be ma equals this net force. And we're solving for m, so m is being multiplied by a. Let's do the opposite. Divide by a. That cancels. So our mass is equal to, we have this net force divided by a. And now we have isolated mass. Here's an equation. We have x is equal to x naught plus v naught t plus 1/2 at squared. Now don't get intimidated because of all the letters. It's the same process here. Now let's say that we're going to solve for v naught. And looking at all the operations taking place there on the right side, we had some additions going on. There's some multiplying going on. So it's reverse PEMDAS. Remember, addition, subtraction, excuse me, is at the end of PEMDAS. So we're going to do that first. So we're going to subtract x naught, and we're going to subtract 1/2 at squared. And we have to do that to both sides. So that will cancel this out here, cancel all that here. That's all together. And let's rewrite it. I kind of ran out of room over here on the left. It'll be x minus x naught minus 1/2 at squared equals, excuse me, all we have left on the right side is v naught t. And now all we have is this multiplying taking place on the right side. So we're going to do the opposite, divide. All of this would be over t, and cancel that out. So v naught is going to equal x minus x naught minus 1/2 at squared all over t. Here's another one. Let's say we have fg is equal to, we have a capital G, m1, m2, all over r squared. And so for this one, let's say we're solving for r. So we're going to have to be careful, it's on the bottom, but it's also squared there. Okay, so we're going to have to be really careful there because we have that extra squared. Let's get rid of the fraction. Multiply both sides by that r squared. So that cancels. If we rewrote it, we'd have r squared fg equals, now over here we have g m1 m2. R squared is being multiplied by fg, so we're going to do the opposite. Do that to both sides. Now we have r squared is equal to g m1 m2 all over fg. And the last step is to get rid of that exponent, and the opposite of that is going to be square root. And all of that will have to go into the square root. So that cancels. So R is going to equal the square root G M1 M2 all over FG. So keep in mind whenever we're solving these equations and manipulating them, these are the important steps here to kind of follow. Identify your variable, identify the operations. Remember, we go in that reverse PEMDAS order. What you do to one side, you have to do to the other. And as you're working through it, cross out everything that gets canceled and rewrite in between those steps.